Hey guys, welcome back to Jyoti classes. And in the last video, we have started with our Laplace transformations and we have covered the 7 formulas for the Laplace transformations. And now today we will be continuing with the few more formulas of the Laplace transformation. These are the formulas we covered in the last class. So I hope you all gone through these formulas. Try to remember all this so that it is easier to solve the problems. Next, let's begin today with few more formulas. And the first formulas for today's class, that is Laplace transformation of a f1 of t, function f1 of t, and b f2 of t, that is a Laplace transformation of the given function b2 and b is a constant, keep it outside. Laplace transformation of f2 of t. Separately we need to find the values. Okay, find the Laplace transformation keeping the constants outside. For in that, one more is the next formula, change in the scalar property. This type of formula we call it as change in the scalar property. How to solve it? If the Laplace transformation of the given function is equal to capital F of x, then replace that the function with the scalar function, that is a of t. Then the formula will be reduced to 1 by a times f of s by a. Okay. Now next, the shifting theorem, Laplace transformation of e to the power of at f of t, where f of s is equal to s minus of a. If f of t is equal to f of s, then exponential e to the power of t into sine of bt, then the value is b by s minus a square plus b square. If the Laplace transformation of e to the power of at into cos of bt, then it is s minus a by s minus a square plus b square. Laplace transformation of e to the power of at to the t to the power of n, that is equal to n factorial by s minus a to the power of n plus 1. Here I am mentioning s, a, b, some, these are the values. These are the values you all will be aware of. Don't worry just seeing the formula from where we got these all values. These are the all values which will be available for with us while solving the questions. Okay, when we solve the questions, we will be going through which is the S value, A value and B value. Okay, few people seeing those values, they say from where we got these and all. So don't worry, we will be having those values for the in a given question itself. Okay, now just recall all the formulas. Okay, next, the 11th formula, that is Laplace transformation of f of t is equal to f of s, and g of t is equal to f of t minus a, where t greater than a, 0 for t less than a. The value is Laplace transformation of gt e to the power of minus as f of s. Next, Laplace transformation of the derivatives. Laplace transformation of f dash of t is equal to Laplace transformation of f of t minus f of 0. Okay. Next, for Laplace transformation of f of to the power of n to the power of t. See, we find the first derivative, we find the second derivative, we find the third derivative. So if I write the formula like how I wrote for f dash of t, then for f double dash of t, then for f triple dash of t, the length of the equation goes on increasing. So rather than that, we can have a generalized formula, that is for the derivatives of the given function f of n of t for the dash. Okay, next for f n of t, s to the power of n, Laplace transformation of f of t minus s to the power of n minus 1 f of 0 minus s to the power of n minus 2 f dash of 0, so on up to minus of f to the power of n minus 1 of 0. Okay, this is the generalized equation. Next, Laplace transformation for the given for the integral part, that is Laplace transformation of f of t is equal to f of s. Then take integral from Laplace transformation from 0 to t, f of t dt is equal to 1 by s f of s. For the Laplace transformation of t dot f of t, then this is the formal Laplace transformation of t to the power of n f of t is equal to 1 minus 1 to the power of n d to the power of n by s to the power of n into f of s. For the Laplace transformation of 1 by t into f of t, if it's a function of time, then the Laplace transformation turns f of s is equal to 1 by t f of t is equal to integral from s to infinity f of s ds. Okay. Next, if it is a unit step function, then u of t minus a is equal to 0 or 1. For 0, t less than a and t greater than or equal to a, it is 1. Okay, let us keep this much for today's video, and we will be continuing with few more formulas in the next part. Thank you guys.